Lesson 112, Angles, Triangles, and Quadrilaterals. The focus for this lesson is for you to make a geometric shape or design, for you to build and identify right angles, obtuse angles, and acute angles, for you to construct with straws and twist ties, right triangles and quadrilaterals, and for you to practice drawing and naming angles. But let's get started with our mental math and fluency by rounding to the nearest 100. First, 2,168. Rounding to the nearest 100, you should always underline the 100 spot, ones, tens, hundreds. Draw an arrow from the 10 spot to the 100 spot, because that's going to tell you this 6 tells you what to do with that 1. And if you look at your roller coaster, you see that the 6 is telling the 1 to go up 1. So your answer should be 2, 2, 0, 0, which we say as 2,200. Look at the next one. Again, ones, tens, hundreds. The 5 is in the hundreds place. The 4 tells you what to do to the 5. 4 on down, we leave it alone. So my answer would be 1, 5, 0, 0, which is 1,500 or 1,500. Pause the tape now and do the next one. And when you're satisfied with your answer, I want you to turn the recording back on and check to make sure you did it right. So again, you underline the hundreds place. The number to its right tells me what to do with that 8. 5 on up tells me to round up 1. So the 9 rounds up, the 8 rounds up to a 9. Your answer is 2,900, which is 2,900. I want you to go over and take 4 of each size straw, take 4 twist ties, and make a design or a geometric shape. Do not bend the straws. Okay, so once you get those straws, I want you to try to put them together and try to make a shape. Pause the tape now and get what you need. In this lesson, you're going to construct many two-dimensional shapes, and you're going to discuss their similarities and differences that you find between the shapes. So take 2 straws and 1 twist tie. Insert the twist tie into one end of each straw to join them together. Now we're going to talk about angles. Angles, so if this is 1 straw and this is the other straw, your twist tie needs to go inside these 2 ends to put them together. This is the angle of those straws. The point here where they come together, where the 2 lines meet, this is called a vertex. If I was to draw it, you can kind of see right here, it looks like the letter V. That is, it's ver, V-E-R, tex, T-E-X. So I'm going to draw, that's this point right here. The part from here into here is the angle. A-N, sorry for my writing, G-L-E. I sure hope I don't get graded on that. All right. So, angle, again, and vertex. A right angle is an angle whose sides form a square corner. Excuse me. So a right angle, you would lay down a sheet of paper or a Post-it note, and if you follow the lines straight down and straight across, mine here is not perfect because this line should be straight up and down. That would be called a right angle. I'm going to try to take that off to make it a little more perfect. Okay, remember mine's not perfect, yours should be. This is a right angle, as long as that's a perfect square in the corner. Similar to a capital letter L. That is a right angle. Lines or line segments that intersect and form right angles are called perpendicular lines. So, if we look at the right angle, these are, if drawn straight, perpendicular lines. I'm going to label the vertex B on this right angle. So I draw my point, I label it B, and I'm going to label a point A on one of the rays. This is one ray going up here. I'm going to label that point A. And on this ray going out this direction, I'm going to label another point C. One name for this angle is written angle ABC. Another name for this angle, and my angles, please forgive me for not having them perfect, could be CBA. Notice, I started with A, went to B in the middle, and then to C. And I reversed it. I went from C back to B and up to A. B is at the vertex, so B needs to be in the middle. The vertex always must be in the middle. Okay, students, now join 3 straws of different lengths from your kit and lay them flat on your desk. What is that shape called? Well, hopefully, you laid one here, possibly, one here, possibly, and one across like this. I'm hoping that you noticed that you just constructed a triangle. See how many different angles you can include in a triangle. You might need to experiment with different straw lengths. So how many right angles can there be in a triangle? Well, if we did it like this, there would be one right here. But remember, you would want to use a straight edge, which is like a ruler, in order to draw that. Because if the lines are not straight, you don't have a true right angle. I am going to label this vertex Y. I'm going to also put an X at this vertex, and I'm going to put a Z at this vertex. Remember, the vertexes are just the corners. Now make a straw construction out of 4 straws and lay these constructions on your desk. What are these shapes called? Well, I'm sorry, I thought I had a blank page here. But if you have any 4-sided shape, you are making a quadrilateral. Remember, quadrilateral is written Q-U-A-D. That's quad. Quad means four, like a four-wheeler. Ril, R-I-L. So we got quadril. And then the last part is lateral. So it's A-T-E-R-A-L. Quadrilateral. That is a four-sided shape. Now it could be a square. It could be a trapezoid. It could be a shape such as what I'm drawing here. Not very well, so bear with me. Or something that looks a little misshapen. Oops, I'm sorry about that. I don't know why it did that. I think I'm getting too close to draw it off to the side. Those are all quadrilaterals. So use various straws to create a four-sided shape. What is this shape called if all are the same size and all angles are right angles? Well, that would be a perfect square. If all lines were the same size, and that's a terrible square, but that's what it's called. If you pull two opposite corners of the square outwards, so if you grabbed a hold of this corner and grabbed a hold of that corner and pulled it outwards, would you have any right angles? No, you're right, you no longer would. The sides are still the same length, but this new shape is called a rhombus. Now use two straws of one length and two straws of another length. Make a quadrilateral with pairs of opposite sides the same length and with four right angles. Hopefully you've noticed that what you've drawn is this shape here, what you constructed, and it's just a rectangle. These two lines and straws are the same length, and these two are the same length, which is a rectangle. If I would pull the two opposite corners in opposite directions and pull these two corners outward, are the angles still right angles? We'll do it. And you're noticing that no, they no longer are. The opposite sides are still the same length. But this new shape is now called a parallelogram. Now make a trapezoid, and that was my lovely one here. Are the right angles in these right angles? Well, in this one, they're definitely not. See, squares have all right angles, but some trapezoids have no right angles, or only two right angles. Are the sides the same length? Well, not in this one. The one on top and the one on bottom are definitely two different lengths. The two on the sides may be the same length. So I want you to look at the pictures of the parallelograms and the kite on page 235 of your student reference book. Pause the tape now and get your student reference book and look at that. Page 235. Pause it now. How are these two figures alike on page 235? Well, they have two pairs of sides that are the same length. How are they different? Well, in the parallelogram, the opposite sides are equal in length. In the kite, the sides equal in length are next to each other. Make a trapezoid and try to make a quadrilateral with exactly 3 right angles. Experiment. Pause it now. Were you able to make a quadrilateral with exactly 3 right angles? You're right, no you weren't. Because when you put the 4th side on it, it automatically makes a right angle. So the figure has 4 right angles, not 3.